Hello everyone, welcome to this lecture. In this lecture, I will show you how to specify your reactions in the simulation basis manager, right? So this first video will be an introduction to reaction specifications, then we'll have subsequent videos, right? So this is just the beginning. Now, if you are modeling processes with reactions or processes that contain reactions, you are expected to specify your components as usual. Choose or select your fluid package, your property package, and then specify the reactions involved in that particular model, right? So that is what you are supposed to do before you go into the simulation environment. Meanwhile, you can actually specify your reaction at any point in the simulation, right? You can start your simulation first and then specify the reaction later, probably at the point where you want to model the reactor involved in that particular simulation, right? You can either specify it before you start the simulation or during the simulation, right? That's how it works. So for reaction processes or simulations that contain reactions, you have these steps to follow, right? You specify your components from either the Hysys databanks or Aspen properties database. You select your fluid package, then you select your reaction model, then you specify the reaction parameters that are associated with that process, right? Depending on the model you are using, there are a lot of things to specify. You can specify stoichiometry, kinetics, right, conversion, and the likes. Then the last thing you will do is to add that reaction. You add it to the property package, right? So that is it. So you add it to the property package. That's how to specify. This is like the generalized procedure to specify your reactions, right? In cases where you have models with reactions, right? So in the Aspen Hysys, we have two types of reaction, right? Reactions or reaction sets. We have two types, right? So when you want to specify your reaction, you click on reactions right here. But before I do that, let me just choose a fluid package for this. I click on add. So our component list was chosen or created using the Aspen Hysys data banks, right? In this particular case, we are using the Hysys data banks, right? So we'll also be choosing from the Hysys data banks as well, right? So I said something in a previous video about the Hysys data banks. I said if you choose a fluid package that is not suitable for that particular component list that you created, the Hysys data bank will give you an error message. So let me illustrate that quickly. Let's see. Okay, yeah, right. So I click on this particular fluid package and it is not compatible with the components in this particular component list that I created, right? And it has told me, or it has shown me, the incompatible components, which are hydrogen and oxygen, right? So in this case, you have two options. Either you change the fluid package or you remove the components from that particular component list, right? So your best option will be to change the fluid package to a more suitable package, right? Because you cannot remove the components from the component list because they are involved in the particular process you want to model, right? So instead, you choose another fluid package, right? and in this case I'm choosing Peng Robinson, which is okay for the components I chose in the component list. So this Hysys data banks helps you to know whether your the fluid package you chose is actually compatible with the components or not, while the Aspen properties database will not give you such notification, right? Any component, any property package you choose will be okay, right? So you would have to be careful when you are using the Aspen properties database. You would have to be sure of the fluid package you are choosing for your components, right? So now, like I was saying, if you are trying to model a process that involves reaction, right? You choose your components, then you choose your fluid package, then you click on reactions, right? So in these reactions, we have two types of reaction in this reaction environment. We have the reaction set and the chemistry set, right? We have the reaction set and the chemistry set. Now, if you go back here, the chemistry set includes dissociation, equilibrium, and salt precipitation, right? What this means is, if you want to specify reactions for dissociation, or you want to specify reactions for equilibrium, or reactions for salt precipitation, you can do that from the chemistry set, right? You can do it from the chemistry set, right? Then you have the reaction set. Now, in the reaction set, we have different kinds of models. We have the conversion reaction model. We have the equilibrium reaction model. We have the heterogeneous catalytic reaction model. We have the kinetic reaction model and the simple rate model. So the reaction set consists of 5 reaction models, while the chemistry set consists of 3, right? So depending on what you are trying to model, you can choose from any of these sets and then specify the reaction before you go into your simulation environment, right? So now, before we go further, there was a notification there for the chemistry set. Chemistry set only works with the Aspen properties database. Now, what that means is, when you are specifying a chemistry set, you must use the Aspen properties database to choose your components and your fluid package, right? In this case, we use the Aspen Hysys data banks, right? We use the Aspen Hysys data bank for both our components and then fluid package. Now, if you want to specify a chemistry set now, right, you use the drop down and click on chemistry set, and then you click add reaction, and then you choose whichever of the models you want. For example, if you want dissociation, you highlight it and then you click add chemistry, then you exit. Now, when you open this to specify, you would notice that you cannot find any components in this form right here, right? It's blank. Now, it is blank because we use the Hysys data banks to choose the components and the fluid package, right? So if you want to make use of chemistry sets, you must use the Aspen properties database. Now, let's go to another case where we use the Aspen properties database. Now, in this other case, I used the Aspen properties database to choose the components, right? If you don't know how to do this, please, I have treated this in a previous video, so you can check back, right, and get to understand how to choose components from the Aspen properties database, right? So in this case, I use the Aspen properties to choose components and also to choose the fluid package, right? So if I want to specify a chemistry set here, all I need to do is click on reaction, then use the drop down and use chemistry, then I click on add, then I choose whichever model I want and I click on add chemistry. Now I open the form and then I want to specify the reaction. I use this drop down and I click on the, for example, here it's asking for the dissociating electrolyte, which normally would be water, for example. Now if I click on it, you will see that this would appear. Now this appears because the components are visible, and they are visible because it is the Aspen properties database that was used to specify the components and the fluid package, right? So that is the first thing to note about the chemistry set. You must make use of the Aspen properties, right, for specification of your property package and your components, right, before you specify the chemistry set you want to specify, right? So that's it for chemistry. Then for reaction, you can use either of them. Let's go back there. For the reaction model, right, you can either use the Hysys data banks or the Aspen properties database. Either of them will work for you, right? But now let me delete this, delete set. Yes, but the Hysys data banks, where you want to specify reaction models, right, you click on add first, you click on add, then you click on add reaction. Now in this case you would have to specify which of the data banks you use to specify your components, right? So if it's Aspen Hysys data banks, it must be activated. If it is the Aspen properties, you click on it. So whichever one you use to specify your components and your fluid package is the one that should be, right, that should be highlighted here in this reactant source, right? So that is what this particular statement here is saying, right? The reactant source that must be selected is the one where the components were chosen from, right? So that's how it works. Let me see. Okay, yes, so you must choose whichever one you selected your components from. In this case, we selected from the Hysys data banks, right? So for example, if you wanted to specify a conversion model, you click on add reaction and then you exit this, right? Then you now double click on this to specify the reaction parameters. Now you will notice that you can find your components here because the reactant source is correct. Now if you use the wrong reactant source, let me delete this and add it again. Add. Okay, let me do that. Delete. If you clicked the wrong reactant source, you will not be able to find your components, right? Right, you see, so it is blank because it is not the correct reactant source, right? So you go back and you specify the reactant source properly. So in this case, we use the Hysys data banks, right? And you will find your components. Now, like I said earlier, for the reaction model, you can use any of them. You can use the Hysys data banks or the Aspen properties to specify your components and your fluid package. All you have to do is to make sure that the correct reactant source is selected before you start specifying your reaction, right? So that's it for that particular one. Then moving on, now the next question will be how to determine which reaction set would be appropriate for your reaction, right? Now, the first thing you want to consider is the kind of reaction you are trying to model or specify for your process, right? So the kind of reaction it is will determine which model you want to use, right? Or it is one of the determining factor of which model you will choose, right? So for example, if you wanted to model the water gas shift reaction, right, you would want to use the equilibrium model, right? Because normally the water gas shift reaction is an equilibrium reaction, right? In real life, it's an equilibrium reaction. So you would want to use the equilibrium model to actually model that kind of process in your simulation, right? So because it is normally an equilibrium reaction, you want to use the equilibrium model. So that's one of the things you consider when you are trying to choose the reaction model you want to use for your process. What kind of reaction is it? So you have to ask yourself that. If you don't know, you will try to do some research and find out the kind of reaction that particular reaction is, right? Then the second thing you can consider is the reaction data available, right? So the reaction data that is available will actually determine which model you would use. For example, if you have a process or a reaction to model and you have the kinetic parameters of such process, you may want to use the kinetic model, or you may want to use the simple rate model, or if you have the catalytic parameters, you may want to use that model as well. So depending on the data you have, in some cases you may just have conversion, and in such a case you would have to use the conversion model, right? So depending on the reaction data you have, that will determine the model you would choose, right? So that is one of the other things you would also have to consider when you are trying to choose a particular model for your process. Then the last one I outlined is how detailed you want your modeling to be, right? So depending on how detailed you want it to be would determine which model you want to choose. So like it said over here, the kinetic and then the heterogeneous catalytic, right? Those two models are one of the most detailed models you can use for your reaction modeling, right? So if you want your modeling to be very, very detailed, you may want to consider using any of those two, either the kinetic or the heterogeneous catalytic, but it will require you to have a lot of data about that particular process. So you would have to do a lot of research in order to get the data that is required, the kinetic parameters that are required for that particular reaction, right? So if you want a very detailed reaction modeling, you want to choose any of those two models, right? So that's it for that. Then what do we have? Okay, for process modeling, now let's look at this. Now for the reaction models, we have 5 reaction models. Now I would like to show you the kind of reactors that are in the software that you can use for those models, right? So in the software you have the PFR, the plug flow reactor, the CSTR, the conversion reactor, the equilibrium reactor, and then the Gibbs reactor, right? So any of these reactors are used for these particular models, right? These reaction models. Now the simple rate model, it goes well with the plug flow reactor or the CSTR. So either the CSTR or the plug flow can be used for the simple rate model. Then the conversion model should be used with the conversion reactor. Then the kinetic right? The kinetic should be used with either the plug flow reactor or the CSTR, right? Same with the heterogeneous catalytic, either the plug flow reactor or the CSTR. Then the equilibrium model can be used with the equilibrium reactor or the Gibbs reactor, right? All these reactors can be found in the reactor section of the model palette, right? The model palette, you can find any of these reactors from the reactor section. Then other equipments you can still use in reaction modeling are the separators, the two-phase, three-phase separator, then the tank, then also distillation columns too. They usually have a reaction section in them, right? So if you want to model reactive distillation, you can also use distillation columns for that. Then also in the reaction models, we have this classification for them for their stoichiometry and kinetics. So for the 5 reaction models, stoichiometry is required for the 5 of them, right? You would have to specify their reactants, products, and then their stoichiometry for the 5 of them. Then for kinetics, you would have to specify kinetics for simple rates or kinetic parameters for simple rates, for kinetic, and for heterogeneous, right? So for those 3 models, you'll be required to specify their kinetics, while for conversion and then equilibrium, kinetics is not required, right? Kinetics is not required, right? So now we'll be looking at these models individually, right? So if we cannot finish in this, we'll continue in a subsequent tutorial. We'll try to look at each of these models individually and how to specify them properly, right? So let's go over to the simulation environment. We'll be starting with the chemistry sets. So for example, we have set 1, and set 1 is dissociation, right? Chemistry dissociation. Now, when you want to specify it, it's simple. It just requires you to specify the components that are required in the process, right? Just specify the components required in the process, then specify their stoichiometric coefficient, right? So though it will require you to specify the particular component that is the dissociating electrolyte, right? This is for dissociation, the dissociation set, right? So once you are done specifying the electrolytes, then you have to specify the reaction components and then their stoichiometric coefficient. Let me try to balance this. Nope. Okay, this should be 0.5. Yeah, so it's balanced, right? So once you are done specifying that and you get this ready message, your dissociation set is fully specified. Now you have this tab by the side called balance. You can use it to balance your equation, right? If I remove this, you can use this balance to balance your equation. You just click on it and then it specifies the last value, but it is used when you have actually specified other values for the components in the process and the unspecified component is remaining 1, right? When the stoichiometry of the unspecified components is remaining 1, what I mean is, let me see. right? So you see now that we have two unspecified components. The balance is inactive. You have to specify your components, and then the unspecified is remaining one. That is when you can use the balance, right? So if I specify for hydrogen is 1, right? The balance becomes active. Then you can click on it, and then it now specifies the rest, right? So that's it. Then here, if you have your temperature approach data, you can actually specify that here, right? But the model can actually run at this point even without the temperature approach. So if you have it, you can specify it, or if you don't, you can leave it empty. Now, once you have fully specified your reaction, you get this ready message, right? This green ready message here, right? Then here you have your balance error to be 0. That would indicate that your equation is balanced. Then your reaction, heat of reaction, is empty until you attach to fluid package, which is one of the steps we have in our general procedure for specifying reactions. You have to add reaction set to active property package, right? So it is at the point where you add it that the reaction or heat of reaction is visible, right? So you come here and click add to FP, and then you click on add set to fluid package. So it says chemistry set cannot be attached to a non-electrolyte Aspen property package, right? So what I will do is I will go back to the fluid package and then change it. I'll change it to electrolyte NRTL. Then I'll come back to check, right? I'll change it to electrolyte NRTL. Where is that? Okay, this is it, right? So I'm changing the fluid package based on the message I got. Then I come back to add to fluid package and I click on it, right? So it has been added to the fluid package. Once it's added, you get this ready message, right? So this is for dissociation, for a dissociation reaction. Then the next is I want to add equilibrium, right? Equilibrium. So for equilibrium, you have to specify the reaction, then the temperature approach as well, and then the equilibrium K, right? The equilibrium K value, right? Now, if you don't have the equilibrium K value, you have to use this Gibbs free energy, right? So in this case, once you specify the reaction, the whole specification will be ready, right? With just the reaction specification. But if you want to specify, or you want to use specific values for K, right, you would have to either use this ln K equation, or you use this one, right? So that is if you have the K values, right? But if you don't have it, you will have to leave it at Gibbs free energy, right? You will leave it at Gibbs free energy. So once you specify the stoichiometric coefficient, you are good. So in this case, you specify the stoichiometric coefficient. Let me see. Okay, this should be 1, right? Yes. -1 actually. Okay, now when you are specifying the stoichiometry of your components, the reactants will go with negative values, right? While the products will be positive. That is how to specify your stoichiometry. reactants are negative, products are positive, right? So once it is balanced, you have your balance error to be 0, right? So you can use your balance error as a guide to know when your equation is balanced, right? So we are okay. But if you choose any of these orders, that is when you will now have to specify more details, right? So if you click on this, you now have this saying not ready, because you now have to input the equilibrium K for this particular reaction. But like I said, if you don't have such data, right? If you don't have such data, you will need to leave it at Gibbs free energy, and then you can start your simulation or your modeling, right? So this is for the equilibrium, right? This equilibrium here is similar to the one in the reaction set, right? This is chemistry set and it has equilibrium. The reaction set also has equilibrium and they are similar actually, right? So the next one is salt. That is salt precipitation, right? Salt precipitation. So you would be required to select the particular salts involved in the process. Then once you do that, the same procedure, you would have to balance your equation. Water is not a salt, right? This is just an illustration, right? So, and then you have to input your K equilibrium if you have those values, right? So once you balance your equation, you should be good, right, to start your modeling. Once the equation is balanced, like I said, if you don't have these values for K, either the one that requires this equation or this one, the one where the K is fixed, just leave it at Gibbs free energy, except you have these values to specify. Except you have these values. If you have them, you can specify them, but if you don't, you just leave it at Gibbs free energy, right? So once you balance your equation, you have the ready message, right? When you are done specifying your reactions or chemistry sets, you can then go to your simulation environment to start your modeling. All you need to do is just click on simulation. But like I said earlier, you can find your reactors in the reactor section of your palette, right? Once you are in the simulation environment, right, just click on reactor and then you can find those reactors here. You have the CSTR, the plug flow, the conversion, right? Let me just get all of them out. So this is the CSTR, then this is the plug flow reactor, this is the conversion reactor as you see on it, then this is the equilibrium reactor, and then the Gibbs reactor, right? So either the equilibrium or the Gibbs reactor can be used for equilibrium models, then the conversion can be used for conversion model, then the CSTR and the PFR can be used for the heterogeneous catalytic model, the kinetic model, then the simple rate model, right? So all these models will be treated in subsequent videos. They will be treated individually so that they can be properly understood, right? So I don't want to give you so much information in just one tutorial video, right? So I will treat each of those models individually, right, in subsequent tutorials. with this, we have come to the end of this particular lecture, right? So if you have questions on what was taught in this tutorial, kindly drop your comments, like this video, share with your friends, then subscribe to this channel, right? Thank you for joining me. Do have a good day.